Hello everyone. Welcome to this week's edition of CamLogic's Tech Tuesdays. My name is Rob Carver and I'm an applications engineer here at CamLogic, and Tech Tuesday is our free weekly 30-minute tips and tricks webinar. Today's topic is generic motion applied to gun drilling. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years. The company was established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from manufacturing to the conception of the idea or design. Because we started towards the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Steinbeckler white and blue light scanners in Creaform for 3D scanning for inspection and quality. Now that you've heard a bit about CamLogic, let's move on to today's topic. Generic motion control. First, let's talk a little bit about GMC, or generic motion control. Usually it's used to move tools around parts that have a complex geometry, or in a multi-axis machine with complex positioning controls. And it's found under the create operation type and operation subtype of mill multi-axis, mill multi-blade, and probing. Gun drilling, as most of you know, is a unique deep hole drilling operation. A gun drill is typically a long hollow tube fitted with a carbide tip. It's then fed into a pilot hole with the spindle off. High pressure coolant is applied through the tool, and the spindle is turned on once it's into the pilot hole, and the tool is fed at a fairly high rate. Once at depth, the spindle is turned off and the tool is retracted and positioned to and into the next pilot hole. Usually this is a single flute tool, so let's see how this is going to work. Here I've got just a basic, it could be a plate for a mold base or something, and we've got some holes through here. These could be coolant holes for a mold base or something of that sort. Under my operation navigator, I've got a pilot drilling operation done. Usually this drill is maybe a couple of thousandths larger than the drill, the gun drill that you're going to use. And this is just a standard run-of-the-mill drilling operation. So we just go through and put little pilot holes about 1.5 inches, in this case about 1.5 inches deep. And usually what I've found, for me personally, the best thing to do, go in and create an operation. Here we have here we find the generic motion under mill multi-blade. Here's the mill multi-axis. That's where I'll be pulling it from. Doesn't really matter where you pull it from. But first thing I kind of like to do is I go into mill control and put a mill control operation in there, and just make sure that my spindle is off. If for some reason it seems like the post wants to pick up an extra operation or something. So I found that just adding this extra spindle off command helps me make sure that my commands come out my post all right. So I want to insert another operation, and let's go in and grab this generic motion. The tool I'm going to use, I've got a 7/16 by 12-inch gun drill, 12-inch gun drill in here. It's going to be a generic motion control. Make sure that my speeds and feeds, my spindle RPMs are all off in this case. Set everything to none. Add a new subtype. And here I'm just going to go linear move to point. I'm going to specify my point. The motion type is going to be traversal. Okay. And so there we see our first point. Now, what I want to do, that kind of gives me a starting point here. So what I can do is I can go in and edit this, and I want to back it up just a little bit. So I'm going to give it, maybe an inch. Okay. Now what I can do is I can copy that, paste it, edit that one, and move it to within a ½ inch. So once you've got this, it's fairly simple. Okay. Go in, this time I'm going to add in a machine control. I'm going to turn my coolant on. I want to make sure it's coolant through. And again, we can go in and move. We can either select the point, because I'm going to at this point go in here, select this again, edit it. This time I'm going to go in. I think I told you my pilot depth was an inch and a half, so I'm going to go in 1.25 inches. Okay. Now I'm going to add in another machine control. This time I'm going to turn my spindle on. And obviously depending on the material, you're going to have to figure out your feeds and speeds. So I'm just going to throw in, a 500 RPMs. Okay. Now we can go in and add in another one. Like you said, this is fairly simple stuff. Select my back depth back here. This time, although, I'm going to use my cutting feed, set a custom speed of, I don't know, maybe 10 inches a minute. I know the gun drills you can go faster than that, and in a lot of materials. Okay, and that's going to take me. You can see my tool tip right here. So I'm going to go in and I'm going to edit this a little bit. Let's go 20 1/4. Okay. I think I told you that my gun drill was 12 inches long. Obviously, I made a mistake. It's longer than that. I think it's like 22 inches long. I had a mistake in my description, but hey, you know what? Everybody's entitled to a little mistake every now and then. As long as I don't crash the machine, I'm good. Okay, let's add another machine control here. This time I'm going to turn my spindle off. Okay, because I want to leave my coolant on for lubrication, but I'm going to turn my spindle off because I'm going to drag it back out of that hole now, and I could actually come back here and copy this one and paste it here. Okay. Actually, you could, to save yourself a little bit of time, if you want, you can go in and once you pick your first point, you can paste and edit all of these. You know, you don't really have to make but one selection in this. It's a fairly simple procedure. Okay, and so that would be about the end of our cycle there. Make sure that I've got my feed rate set the way I want. It's a traversal. Maybe, you know, it's not a rapid move. I can go ahead and put a custom feed rate in there. Maybe I want to feed it back out at 5 inches a minute, or 2 inches a minute, or whatever it is, whatever you feel is like a safe retract move. You know, you might have chips in there. You don't want to jam the tool up and on any chips that might be in there. Of course, with the high speed, with the high pressure coolant, you shouldn't have any chips back in there. Okay. And so here we can play our it's just like our visualization. Our verification. We can play our tool path here. Okay. Go back up to the top. All right, there we go. There's one. So, you know, we could go through and do the same thing all the way through here, but I don't really want to do that. So we've got 10 holes here. So let's just go in here, object. Let's do a transform. I'm going to translate it delta, and you notice I've got a little PMI going here that tells me what my spacing is on my holes. So I've got my spacing here, my X delta 2 1/4, and I'm going to use instance rather than move or copy. I'm going to use instance so I can hold on to, you know, these are going to be associative copies, and I'm going to have 10 instances. I've got 10 holes here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I've got 11 holes here. 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got my first hole. And then the remaining, your remaining count is the number of instances, okay? And there we go. And finally, if I have another mill control, I can copy this, paste it, edit it, and my spindle should be off already, but I want to make sure my coolant gets turned off too. And let's generate that. Okay. Oop, didn't generate it. There we go. So if I go to my program order view, give it a tool path, verify. Here's our pilot drilling operation. Now here's our gun drilling operation. All right. Now, however, the proof is in the pudding. So if we were to post-process this, we're looking for specific output. And in my experience, we've always done this. Back where I worked, we did these on 4-axis machines in castings, putting in oil galleys, that sort of thing. You might do this on a 3-axis horizontal, whatever your particular machine's going to be. I'm going to pick a 4-axis mill post-processor, just out-of-the-box post-processor. I haven't done anything special to this. Here's my output file. So here's our first gun drilling, or our pilot drilling operation. This is a standard format, okay? So then we go in here. Here's our second tool. We get a spindle 0 M3 command. Here's our H1 and our positioning. The M26 is our coolant through command, and you see that it's actually kind of rapided into that hole. I'm not so sure I like that, so I might have to go back in and change my feed rates here. But then my spindle command comes on, my feed rate comes on. We also get the added M8 command here. In my experience, that's not a bad thing. The more coolant you got flooding on that thing, the better. And you still have this M26 here. So let's go back in and see if we can't get our feed rate to come in on that line. I'd like that to be a feed move rather than a rapid move. So I think that was we're going to go in and edit this, and we're going to get a note here. It's going to tell us that it's all instances of the operation generic motion will be edited, and this is the reason why I chose to make an instance of it rather than just copies. So all I have to do is edit this one. Let's see, is that the one? No, that's moving to within a ½ inch. That can still be a rapid move. So let's go to this one. That one's 1¼ inch. You see, I'm going to go in and I'm going to use a custom move here of maybe. I'll be careful here. I don't want to ram into a chip or something of that sort. So let's just custom feed rate. I should have coolant blowing on, turned on there, so it should be blowing anything out of there. Perhaps we'll make it engage motion type. Hit OK. Okay. Let's regenerate all these. Okay. Come back in. Let's process it again. And there we go. Now I've got my feed rate there. I'm feeding in at 2 inches a minute. Okay. This is I think probably one of the simplest methods that I can think of to do a series of gun drilling operations without having to do some major reprogramming of the post-processors. Now, the only thing I can think of that might give somebody, an error or something would possibly be this S0 M3 command here. But that, that's one line that you might have to edit out of there, and perhaps some creative post-process writing with PostBuilder would go a long ways to even solve that problem. But to me, this is a This is a fairly simple, down and dirty method of doing gun drilling operations. And so with that, that concludes this part of my demo, so I'll get back into my presentation. We can't emphasize enough the importance of training to get the most out of today's technology here at CamLogic. It is well documented that training helps improve the speed of use, increases the efficiency, provides faster problem resolution, and leads to fewer support calls, all of which positively affect your company's productivity, return on your investment, and the bottom line. At CamLogic, we offer a wide variety of hands-on instruction-intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training labs located throughout the Midwest. For more information or to register, please visit our website at www.camlogic.com, or you can call us for more information at 248-969-9201. Today's webinar can be found on YouTube, usually within 24 hours of the broadcast, and check out CamLogic on YouTube for other past webinars as well. And thank you for joining us today. If you have any questions, please feel free to email me or call me at any time. Be sure to visit our website at www.camlogic.com, and we can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. This concludes today's edition of Tech Tuesday. Thanks again for tuning in, and have a great day.